Good morning, good afternoon, good evening, depending on where you're located in the country. I'd like to introduce myself. My name is Frank Corkery. I have been with Teel since 2018, and I've been doing forensics for the last 15 or 16 years. And probably I may know some of the attendees today. Just like to say hi. Let you know that in the background we've got Angie from Teel is running all our tech for us today and managing the webinar. And I've got Dave Burton sitting in Toronto, handling all of the Q&As that are going to come in. And without further ado, we're going to get going. All right, so obviously the topic for conversation today is vehicle forensics, and specifically advanced acquisition techniques. We were talking earlier between myself, Angie, and Dave about how much vehicle forensics has come to the forefront in the last little while. It's to the point where it's catching on as a tool with forensics units quite a bit. It's similar to when smartphones started doing an uptick and eventually overtook computers. So what we're seeing now is a lot of conversation about vehicle forensics, and our investigators are quite aware that there is an option out there for doing vehicle forensics. And once that starts happening, then we get a lot more people knocking on the door to examine vehicles. So for those of you less familiar with Teel, Teel's been doing digital forensics training. We've been offering tools and services since 2006. There's Teel Technologies Europe, Canada, and US. Within Canada, we do have our classrooms in Toronto. We just have a new classroom that's opened up. Dave was there just a few weeks ago, breaking it in with the first class, and quite happy with how the class is set up and how it's been working. This is just a quick overview of myself. Mostly I do services with Teel, help with sales on the technical side, so speaking with clients, especially our French-speaking clients, and finding out what the needs are. So I just wanted to let you know that we're not going to be getting, obviously, deep into the weeds here with vehicle forensics, because we don't want to actually teach our course online through a 45-minute webinar. So it's going to be a good overview on what it's about, what you're likely to see, and maybe give you an idea of what you're going to be learning on the vehicle course that we do. So, very similar to other devices, why are we using advanced data extraction for vehicles? Obviously, we're dealing with passwords, we're dealing with encryptions, devices that are not supported by over-the-counter solutions, unsupported chips, disabled communication protocols. Again, you have a variant or a device that's not supported by one of the few over-the-counter solutions out there. And then we also have broken or damaged devices that come into it. So you'll be looking at doing more than, plug and play. Phones these days have become what Bob likes to call Nintendo forensics. A lot of people plugging things in, pressing a button, getting the data, and just handing over their dump to their investigators. So we're beyond that. So one of the questions we have to ask is, is it really necessary to go to the extreme of advanced data extraction for vehicles? And the answer is never straightforward when it comes to forensics. Everybody that's on this webinar that has done forensics has said this to their boss at one point in time. Well, it depends. Every situation is going to be different. How important is the data is one of the big questions that's going to come out there. How much, how important is this data for your case? Is it an extra nail in the coffin, or is it the other end of the extreme where it's going to be the key evidence? The other thing is going to be what is the cost? What is the cost of getting the data? What is the cost of the training? What is the cost of the equipment? What is the cost in time? So this comes in probably a little bit more on our private sector clients. So they're going to be looking at a cost analysis. Do I want to spend X thousands of dollars to get the possibility of finding the information I'm looking for? So we're talking maybe an insurance company and whatnot. There is probably a little bit of balance of what do I want to expend here to get this data. And where is it useful for? It's useful pretty much everywhere now. It used to be that we used to say what happens in Vegas stays in Vegas, or then it became what happens in Vegas ends up on YouTube. Now it's rare that you're going to get a case, criminal case, where you don't have at least a phone involved. And more now, you've got vehicle data that can be used in your cases, whether that be strictly from an auto theft, an accident reconstruction, any type of criminal offense, or any case where there's a vehicle involved. Dave had a really good example he was talking about when he was working with Peel, and back in the early days of GPS, where they were able to track a suspect's or an accused's full path that he followed in a homicide investigation, just by using the breadcrumbs that were stored within the GPS unit. So getting back to vehicle forensics, we're looking at removing data from chips. And because we're looking at chips that are located on printed circuit boards, we're looking mainly at in-system programming, ISP, and we're looking at chip-off as our main advanced methods of getting the data. We think about vehicle forensics, the first thing that comes to mind is the infotainment center. So what we're looking at the infotainment center. We realize that it's the main interface between the user and the vehicle. There's also the main point of connectivity between the vehicle and a mobile device. It's obviously used for entertainment, but it also has some vehicle controls and settings, plus a bit more. It's the often the built-in navigation systems is what we're looking at, and that can be a wealth of information can be stored on the built-in navigation systems. Typically, we're talking satellite. Way back when it was a little different when these first came in, but generally we're talking about satellite navigation. I mentioned that Dave had a case where the path was used following breadcrumbs, so that Dave might correct me here. I'll get him to jump in. I think he said it was a Garmin, and it was collecting, registering waypoints at a specific frequency. So even though the person hasn't plotted a path or selected a destination, doesn't mean that your GPS is not collecting information in the as waypoints. And then beyond the infotainment system, we're seeing in vehicles is many ECUs, a lot of computer systems or computer modules involved in the system on the car. They are mini computers in themselves. They're quite evolved and have become quite sophisticated. Probably, especially over the last, I would say, last 5 years or so. So, it used to be where we would find a lot of electronics in mostly higher end vehicles, and now we're finding them in everything. So some of the things that you're going to find in the electronic control units, engine control modules, are going to be systems that control specific types of activities or systems within the vehicle. Door control, engine control, power steering, there's airbag. If I look at BMW, they have the footwell module, I believe it's FRM, which controls all sorts of things, including all the lighting, the door locks, and a number of other things. So sometimes you might have numerous things controlled by an ECU, or you might have just one specific set of systems, such as maybe an airbag module on one ECU. So, what are we finding on them? Well, obviously, we've got a microcontroller. There's some type of memory, whether it be SRAM, EEPROM, flash memory, and where are we going? We're going to the flash memory to extract the data that we want to use. There's different types of inputs on them. There's power. Sometimes there's digital. Sometimes there's always digital. It can also be analog. The outputs can be to their actuator drivers, drivers for servo motors, logic outputs. There's different communication links, and then within the software that's embedded, other than user software, we've got bootloaders and we've got configuration data. I was just reading up on the BMW footwell modules, which tend to fail quite often. They tend to fail because of bootloader issues and require a reflash to get them up and running again, a reflash of the EEPROM. Then we have to, think about how do these modules work together, or how do they work individually. First of all, the data is transferred back and forth between modules using a bus. They can be either high-speed bus lines, so critical information like speed, braking, collision avoidance, so the information that's coming in from LiDAR on the front of the vehicles. And they can be on low-speed bus lines, such as information being sent to air conditioning or to door locks, or that type of information. And for those of you who are car buffs, you've probably heard the term CAN bus for communicating with the vehicle. Well, the CAN is the controller area networks, another type of network. It is the vehicle standards that we're dealing with pretty much across the industry. And it's what allows the different modules the capability to communicate with each other and to provide information needed from one module to another. So, it's your vehicle is looking at, accelerator pedal position. What's the brake pedal status? what is, a button event? Are you pushing on the starter button? If you've got a starter button that fails, you're not getting the signal going to start the engine. What are the fuel levels, the headlamp status? Are the headlights on? When the headlights are on or when there's rain detected, it turns on wipers. Very simple one would be, what's the brake pedal status? So the brake pedal is showing that the brake is activated, that the car is in parked, and now the signal can be sent that says you can now start the vehicle. And what you have to remember is all of these things, these activities that are taking place are being transmitted from one to the other, which tends to mean that at some point it may be information that could be written somewhere. We talked about all of the types of events that can be happening on a vehicle, that they're being stored somewhere, they're being written somewhere. Sometimes it's information that's being written that's meant to be stored and read. Sometimes it's not information that needs to be stored on a longer term basis. But where does it get stored? Well, just like anything other electronic device, it's being stored in flash memory. And that is our focus, is flash memory. We'll get into talking about the intricacies of flash memory, but it is good to know how flash memory works, how data gets stored on flash memory, that how it gets erased. Data gets erased by page on a flash memory versus by, I want to delete a text message on a phone. It's not just the text message; it would be eventually the page that would get erased. So, what type of extraction methods are we going to be using on a vehicle forensics or vehicle examination? Well, that's going to be determined by the type of chip. Is it eMMC, so multimedia card? Is it eMCP, multi-chip embedded multi-chip package? Is it a not NAND or NOR chip? Is it UFS, so universal flash storage? Is it a system on a chip? What kind of chip? So that's where once you've removed the device or the module from the vehicle and you opened it up, taking the case off, and you looked at the PCB, where you're going to have to do a little bit of detective work, figure out which chips are on there, what are the markings on them, do a little research, and find out what is likely to be storing your data. So, why would I use ISP in system programming? Well, I'll use it because it's non-destructive. So I'm not going to destroy the probably fairly expensive piece of hardware I'm dealing with. And if it's an eMMC or an eMCP chip, I'll likely be going ISP. When would I do chip off? Well, there's no other solution available. We've got destruction of the device or the vehicle, and possibly partial destruction of the module that we've taken out, that the module is not working, so you can't use a commercial tool, or you just don't have eMMC or eMCP chip. And there are going to be cases at times where even if it is eMMC or eMCP, where you will go to chip off. And we'll touch on that as we go forward. And those of you that are on the course who've taken either ISP or the chip off course will be in a good position to to go forward and start doing vehicle forensics, at least for the first step. For getting to where the data resides. So I mentioned ISP. We're just going to say that earlier I said, well, do an overview of it, of what we're talking about with vehicle forensics. So it's non-destructive, and it's a way where we can read the data directly from the chip without removing the chip. The good thing is standardization within the electronics industry lets us know that a specific type of BGH pattern, ball grid array, is going to have a common from one device to the other is going to have the same pinout. So your ground is going to be at the same location on the chip. Your clock is going to be there. Your data out. All of these, no matter who's made the chip, if it's a BGA 169, it's a BGA 169, and the pinouts are going to be the same. I talked about ISP being used for eMMC or eMCP. Yeah, it can be done. That's ideally what you want to do. But at some point in time, somebody's going to be the first one to do a specific module. If you're the first person doing that device, or you don't know if anybody else has done it, you are going to have to either have an exemplar where you can remove the chip and trace from on the board where are your pinouts. For at least the first time you do the vehicle, you'll have to do a chip off to do that. The thing with ISP is it can be very time consuming, and it requires a lot of work and some very good eyes. I talked about you need to find the pinouts, the contact points. You need to do this through back probing from where the chip is located to a point nearby the chip, either often on the end of a resistor capacitor, some other point, and then you have to create your device pinout, map everything, and get ready to do the read. It takes some good eyes to do the soldering. It takes a microscope, because I don't know if you can see the size of the wires here. You're talking about hair wires, extremely fine. The good thing is it's standard communication protocols to these chips, so it's not that we're going to have issues running into reading from the chip or requesting the information from the chip. Generally, the memory is going to be read using a flasher box like a Medusa Pro or something similar. This is a BGA 221. This is actually an eMMC direct, so you're reading, instead of doing your pinouts on the board, what we've done is we've gone directly to solder to the chip to do the read. Generally, you would be doing the read in this manner, where you're not removing the chip and you're doing it through the pinouts that you've mapped. And as you can see on the chip here, I don't know if it's clear enough when I zoom in. So you can see the ground, all the grounds are green, and you're looking at the supply are red on this. So it's possible to get different options on your pinouts. This is I think I've got a couple examples here of some of the pinouts on this from a Toyota RAV4. So this is the chip we're looking at here on the left, and the actual pinouts that have been mapped nearby. We'll go to a little bigger diagram next from a Uconnect system. The Uconnect systems typically found in Chrysler products, where you can see the chip in the middle, and then where the points have been mapped out outside it. And I did talk about chip off before talking the ISP, and that's again fairly common that you would be doing for a first time on a specific on a specific module. So the thing to remember is chip off is destructive. Although depending on what the device is, a chip on is possible. It's not exactly necessarily the safest thing to be doing from a liability standpoint, depending on what type of chip you're looking at removing. And what we're doing is we're acquiring the data through a strictly destructive method, removing the chip, and we're reading directly from the chip. So what we need is we need an adapter for the specific type of chip, and when I'm talking, is what kind of BGA chip is it? Whether it's BGA, a TSOP, whatnot. You will need the proper programmer that can read it and the proper adapter. It's really a quick extraction method. When we compare it, I guess, to ISP, it will read a little faster, although fast is relative. Generally used as a last resort because it is a destructive method. The one thing it does require, though, is that your chip be intact. So if your chip is snapped in two, then that's generally something that's going to be a game-ending proposition. And you definitely are going to need the proper programmer and the adapter. So again, you're going to be needing to do research on the chip. Obviously, you want to research your chip before you remove it to make sure that you've got the proper equipment, the proper programmer, the proper adapters to read the chip, or that somebody you're working with or has it, or that it's something that you can get. Again, it's taught as a destructive process, and can't hammer that home enough. Is that you need to let whoever's bringing the device to you know that it is a destructive process. If you have to go to chip off, that you are going to be making the device unusable. And that may be something, if you're in law enforcement, that you want to talk to your investigators on, if they're going to be writing papers, is let them know that you're looking at possibly a destructive method in getting the information. And we kind of looked at it in conversation. We've talked about this amongst ourselves, myself, Dave, Angie. Is it similar to you're seizing a vault or a safe, and you want to get at the information that's inside it? And well, it may be a destructive method to get the doors open and get to that data. So it's always good to let your investigators know that is what you're looking at, and to understand what the policies are in your agency around doing that. So when we're talking about chips, there's a number of different chips that are out there. When I first did chip off, TSOP was what we were seeing on the phones. And then that quickly moved, and I'm not talking that long ago, 15 years ago, that quickly moved to ball grid array. There's numbers of different ball grid array patterns that are out there, which means there's a number of different adapters. The same thing with TSOP, so thin small outline packages, where you've got instead of having the connections on the bottom, you've got them on the end, like we do here, the end of the chip. The good thing is these tend to be a little easier to remove than the BGAs, depending on what type of, whether there's any types of epoxy or whatnot holding the chips in place. Another one that you may come across that you've not come across too much are the small outline integrated circuits. So look a bit like the TSOP chips in that they've got the connections on the outside of the chip, or a system on a chip. Again, they're fairly easy to remove. I've heard some people say that depending on what chip you're removing, some of them can be removed by just a warm breath. So you're not needing to put the heat in it that we used to have to put into years ago when doing chip off. A damaged ECU, I was talking to Bob about this, and he's talked about coming across a damaged ECU for an airbag module, where they've managed to transplant the chip to a working module and then use a commercial tool to read the data. So there are commercial tools out there that allow you to read some data from the tools. When I talk in commercial tools, I'm not talking commercial forensics tools. I'm thinking tools made by companies like Bosch for doing vehicles. When it comes to chip off, again, some of the programmers we're looking at. There's the UP 828 family of programmers, 828P in this case, and as you know, each different type of BGA pinout will have its own adapter. And over time, agencies tend to, when they start up doing chip off, they'll tend to buy, what are the main programmers that I need and the main types of chips that I'm coming across. We at Teel can help you out with that if you're starting out, and which chips you're likely to see the most of to get you a package that would be good for you to start off. Some of the other devices we're seeing are the RT809H. Again, we'll cover a different set of chips. There are some other readers out there. We do have readers like the Dataprog as well, or programmers, and it's important to remember that the term is programmer. And being that it's a programmer, it can not only read, it can also write. So you want to be careful that you don't hit the right button and lose all of your data after all your hard work of removing a chip and getting it ready for a read. Hey, look at this. Again, it's a destructive process. Although you can do a chip on, the last thing you want to be doing is putting a chip on device back into a vehicle and not knowing what the impact is going to be on that vehicle's drivability and what kind of liability may be involved in that. We talked about chips, but there is still a number of systems out there that are using hard drives. They're using hard drives still within the systems, and they're storing data on hard drives. So it is something that can be seen. And if you can see right here that this here is using the Atola to look at this device. So there are a number of tools that you may be using to read your data. Internal hard drives. The nice thing is that you can use traditional forensic data extraction methods. SD cards. You will probably come across some devices that have SD cards right in the on the device itself, or an SD card slot where you can put information into a device. There is information out there that some manufacturers, I've not come across it in the wild. When they're using their SD cards, they're locking the cards down using a SD protocol called Command 42. And what's interesting about Command 42 is if you're to take a SD card that's been locked with Command 42 and try to read it with a system that's Windows, Mac, or Linux based, it will not see that. It will not see that it's been locked. It'll look like you've got a SD card with nothing on it, no partitions, whatnot. So something to be aware of. The good tool is we've actually got a great Canadian tool out there that can identify devices, SD cards that are using Command 42. And that is from SCG here in Ottawa. And they have their CFID, the Covert Forensic Imaging Device, that does have the ability to lock and unlock devices, SD cards using Command 42, and it has a brute force functionality as well. So if you do have one, keep that in mind, whether it be for vehicle forensics or anytime an SD card comes across the desk and it looks like there's nothing on it. So now we get to the fun part. It's kind of like the coyote and the roadrunner. The coyote finally catches the roadrunner and he says, you know, now that I've caught him, what do I do with him? Well, it's like that with vehicle forensics. Once you've been able to extract the data, the fun begins. So it's decoding the data. And again, all is not created equal. Depending on what type of memory device you're dealing with, what kind of device you've got, you know, who's the manufacturer, what type of equipment were you dealing with, the type of data and encoding can be very different from one to the other. You know, there are automated tools out there. If you've got Burla Ivy software, you could get lucky where you've got a device that maybe you didn't use their tool to do the data extraction, but they are able to parse it. Then it's just a matter of importing the data into that tool and parsing the data that way. In this case, you can see it's 2017 Mazda CX-9. But if you don't, you know, what do? Well, then you're getting back to regular forensics, old school forensics, where you actually have to do the legwork, where you have to have a good understanding of how to find information. X-Ways has been turned out to be a really powerful tool in looking at vehicle data, in being able to recognize file systems and at least do that first part for you. In this example, we're looking at a 29 Dodge Charger Hellcat with a Uconnect device on it, infotainment system, and we're looking at a QNX file system. So QNX is a Canadian company purchased by BlackBerry, and it's an operating system you're going to find in a very, very large number of vehicles. Probably the majority of vehicles out there have some form of QNX being run in it. And now back to the Canadian Police College and fun with hex, or fun with ASCII, fun with carving and manual carving. So, you know, you want to have a good knowledge on how to do that. You know, you can look at your data in hex view. You can run your keyword searches. So you look for, do keyword searches. You can look for repeating patterns. Like we used to do with, let's say, Samsung PDU encoded text messages, where you were looking for a header of a PDU message, and once you found the header, you knew how many bytes that you had to sweep. Well, it's the same thing. You're going back to what you've learned in forensics, how to do carving, how to search for keywords, and then trying to find repeating patterns. You know, are you looking for telephone numbers? Are you looking for headers? You know, how is the information stored? Are you looking for GPS? Are you looking for home, the word home? What words are you looking for? You know, and then the other thing you have to think about is what do you think, what should you expect to find? And again, what you're going to expect to find will depend on which ECU you're looking at. What type of data should this ECU be storing? You know, you're not going to find text messages on a airbag module. Do you want to be looking at an airbag module for an investigation where you're doing looking for you know, who is in a vehicle? So which devices were connected to a vehicle? You want to know what type is this as an aftermarket vehicle, infotainment system? What are its capabilities? You know, again, do your research. For the OEM devices, what type of information will you be able to find there? Again, doing a little bit of research on what are the capabilities. Is it running CarPlay? Is it running Android Auto? Does it have its own system? You know, the major players in the infotainment systems, the navigation. There are a number of players out there. There's Harman. Alpine is huge, and you're going to find them in multiple vehicles. Continental, Panasonic, Garmin. If I'm not mistaken, when I'm talking about Apple, their navigation is based on the TomTom systems. You know, LG. There's a number of companies out there. You may also come across devices. We've seen this in the past where you've taken a device out and you're looking through the images. You've taken it out of a Maserati, and then you realize that there are a bunch of different logos from different vehicle manufacturers in there. So that's an indicator that you may see the same device in multiple vehicles, and each one may have its own differences from one vehicle or one manufacturer to the next, even though it's the same, let's say, Alpine device. You know, what operating systems are we going to see? We're going to see Android. We're going to see Apple. I talked about that. Android might be operating the whole system. It might just be Android Auto. It might be just Apple CarPlay. It could be a Linux operating system for the head unit, Windows, or Unix. You know, I mentioned QNX. QNX is huge out there. And then on top of all that, what you get is you get vehicle manufacturers start with a specific, or I should say the vehicle manufacturers, the manufacturers of devices in the vehicle start with a specific baseline. Let's say they're starting with Android, and then they'll add their own flavor, similar to what we're seeing in different Android versions from different manufacturers. You know, where's the data stored? Is it stored if it's are we finding it in free space and unallocated space? Yeah, we're finding some there. Are we getting it from log files? Are we getting GPS information? Are they JSON files? Are they held in SQLite databases? And as you know, SQLite is being used everywhere. And, you know, we're at the point where a lot of the tools for mobile do a pretty good job at getting through, you know, some of the SQLite, but having a good understanding of SQLite is really going to help when it comes to vehicle forensics, to looking through any recovered SQLite databases. You know, a toolkit like Sanderson Forensics, the forensic toolkit for SQLite, whether it be the forensic browser, the forensic recovery, or forensic explorer, are great tools for looking at SQL databases in a way that you're not going to change the information. You know, not many people think about the fact that they need to look at the WAL files or shim files in combination with the SQLite DB file they've taken. So it's incumbent upon us to go back to school and make sure we're up to date on our training on our understandings of SQLite, or that we have somebody in our office or somebody that's a resource person that we can go to. What are we trying to do? What are we trying to find out with the data, and what can the data tell us? Well, it can put us, a driver or a passenger in a vehicle, maybe through a cell phone connection. We can maybe get the mobile phone communications from the devices in the vehicle. I mentioned earlier breadcrumb of travel. Even though they're not using the navigation system to actively navigate. We get data for accident reconstruction. What kind of driver inputs are we having here? Are we having seat belts put on? Are we having people sitting in certain positions? When I'm sitting in the passenger seat, there's an activation there that says, hey, I weigh over a certain amount of weight, and now I'm going to activate the airbag. So I know I've got somebody sitting in the passenger seat. Can we put the vehicle in a specific location? What devices are being synced? If we look at, I think we got it right here. Look at this information here. Draw it first, and then I'll zoom it. So what devices are being connected to this vehicle? Key fob information. As you know, a lot of vehicles these days, you've got two key fobs. One will be driver one will be driver two, and the key fob will be associated to specific settings in the vehicle. So which key fob was in it might help us know, if somebody was arrested and they've got a specific key fob and it says, driver one on it. Well, was the driver one the last key fob used in the vehicle? When we're dealing with stolen vehicles or people changing mileage, we're looking at what's the actual track mileage. Is it different than what's on the screen? So basically it comes down to, if it's got a PCB on it and it's got some kind of flash memory, then there's going to be recoverable data. And what you get from the recoverable data is going to depend a lot on your knowledge as a forensic examiner or analyst, how you're trained in being able to get data from vehicles, and then as well as knowing what tools do I need to use, what software do I need to use to examine my data, what are my best practices for examining data. We've got quite a few people on the presentation today. One of the things that I want to remind you is if you're law enforcement, if you're government, military, please reach out if you haven't already and join Teel's Google group on physical and raw mobile, the physical raw mobile forensics group. And there's just an amazing amount of resources on that group, people that are sharing information on a regular basis. If you've come across a vehicle for the first time, you've come across a Mercedes or whatnot, that you've got to do, there's a good chance, unless it's a brand new vehicle, that somebody else has done it. Somebody else has done the work, the extraction, has done the pinouts, and can share them with you so that you can do an ISP. And you have to keep in mind that not only are the variations in manufacturers, but even within a specific year, a year of a model, is you might find differences in the infotainment systems. You might find a different chip was used. Maybe the same type of BGA, but it might be a different manufacturer. it might be a change in the type of modules being used because of, especially in the last few years with the chip shortages, there could be differences from one model to the next. So a group like that is a great resource for you to seek assistance. You can always send a message to Teel. Teel Canada is here, and we work with law enforcement. We are law enforcement, retired and current law enforcement employees, and we're there to assist you as much as we can. And if you've got a question about something, we're happy to try to answer that question. So please reach out to us. As far as courses, upcoming courses, just had one in Victoria in October. The next one in Victoria is in February. Then we have November of 2024. There's 3 upcoming courses in our Mississauga classroom as well. So please reach out to us. You can look at the digital forensics training down here for our upcoming courses. If you've not done it, you might want to look at doing, if you're thinking about doing vehicle forensics, doing the chip-off course or the ISP in-system programming course. And also know that Teel does do services directed to law enforcement. We do them on a very regular basis. Sometimes it'll come down to you may not have the training or skill level to do a specific type of vehicle, and it may be more cost and time effective to farm out one analysis or one extraction. You may have the all the training to do the analysis. Sometimes we'll do that. We'll do the data extraction and then provide that to the agency for doing their own analysis. Budget cuts are big these days. If you're a small unit and you don't have the budget to invest into this, that's another place where we can help out. I'd like to give also a big thank you to Maggie Gaffney, who has put this presentation together. I tweaked a little bit just for the Canadian audience and for what we wanted to do today. So thanks to Maggie putting this together. And I'd like to thank everybody for joining us today. If you do have any questions, again, you can send myself an email. I didn't put Dave's number, so dave.burton@Teel Technologies Canada, teeltechcanada.com, general info or training or services at Teel Tech Canada. And as I said, the Physical and Raw Mobile Forensics Group, join the community. It doesn't cost you anything to join. What will be required is to let us know what agency you're from, so that we can you can be vetted and approved. There's about 3,000 members on the group, and there is a plethora of information out there, probably from people you already know as well. All right. Well, thank you, Dave, and thank you, Angie. Thanks to Maggie, and thanks to John, and definitely thanks to Bob. I appreciate having the opportunity to present today. And with that note, we're going to end the presentation, and it will be available on our YouTube channel. Thanks again for attending.